Hello students, welcome to Educate. Today we are going to do numericals of chapter 4 of class 12 physics. So let's start. The first question is a circular coil of wire consisting of 100 turns, each of radius 8 cm, carries a current of 0.4 ampere. What is the magnitude of the magnetic field B at the center of the coil? So we have to find out B, and if you remember, at the center of coil, magnetic field is given by mu naught Ni divided by 2R. Here we have information. Mu naught will be 4 pi into 10 to the power minus 7 into number of turns is 100 into current is 0.4 divided by twice of radius. So radius is 0.08. Right. Now let's evaluate it. So 4 into 3.14 into 0.4 divided by 2 into 0.08 multiplied by 10 to the power minus 5. These two powers. Now we can cancel the zeros, means we can cancel the decimal places here. So 2 places, 2 places. Then this will give 1 power negative. So we can write it 4 into 314 into 4 divided by 2 into 8 0 into 10 to the power minus 5. Right. Now we can cancel it. 2 to the 2 40 times, 4 10 times. So this will become 31.4 into 10 to the power minus 5 Tesla. Right? So I think you have understood. Let's see second question. Second question says a long straight wire carries a current of 35 ampere. What is the magnitude of field B at a point 20 centimeter from the wire? So here it is the case when there is infinite long wire and at certain distance r we have to find out magnetic field. So in such case B is given by mu naught times I divided by 2 pi r. Right. So let's put the values. So B equal to mu naught is mu naught upon 2 pi. We can do one thing, we can multiply here 2 and here 2. So mu naught upon 4 pi, that is equal to 10 power minus 7 times 2 into current. Current is 35 divided by R is 20 centimeter 0.2. Then 2 it will cancel 10 times. So this will become 350 into 10 to the power minus 7. So 2 places decimal. So 3.5 into 10 to the power minus 5 Tesla. Right? So question is simple. Now we are going to see third question. Third question says a long straight wire in the horizontal plane carries a current of 50 ampere in north to south direction. Give the magnitude and direction of B at point 2.5 meter east of the wire. So if you remember the concept how to find the direction, if you remember it, so the rule is that suppose you have a wire and current is in this direction, then here to the right of the wire field will be perpendicular down, and to the left of the wire field will be perpendicular up. Similarly, so here it is very simple. You can draw field lines like this, and along the tangent there will be magnetic field. So you can easily find. So here our concern is to find the current, sorry, not current but magnetic field due to current carrying conductor. So B equal to mu naught I divided by 2 pi r. Right. So let's put the values. Mu naught 2 pi we can multiply by 2. So this will become mu naught upon 4 pi times 2i divided by R. Right, mu naught upon 4 pi 10 power minus 7 into twice of current, and current is given 50 ampere divided by R is separation 2.5 meter. Right, so we can cancel it 20 times, so this will become 40 into 10 to the power minus 7 Tesla. We can write in standard form, so it will become 4.0 into 10 to the power minus 6 Tesla. Question number 4. Question number 4 says, a horizontal overhead power line carries a current of 90 ampere in east to west direction. What is the magnitude and direction of magnetic field due to the current 1.5 meter below the line? So same concept we have to apply. V equal to mu naught I divided by 2 pi r. And what we do, we multiply by 2 in numerator and in denominator, mu naught into 2I divided by 4 pi times r. Right, then let's put the values. Mu naught upon 4 pi 10 to the power minus 7 into twice of current. So what is current here? Current is 90 ampere divided by distance is 1.5 meter. So 1560 times 62 is 120. So 120 into 10 to the power minus 7, or 1.20 into 10 to the power minus 5 Tesla. Right? So you have understood. Next question is 4.5. What is the magnitude of magnetic force per unit length on a wire carrying current of 8 ampere and making an angle of 30 degree with the direction of a uniform magnetic field of 0.15 Tesla? Suppose direction of magnetic field is like this. This is uniform magnetic field, and there is a wire like this. So we consider certain length of wire. Suppose we consider this portion. So here magnetic force per unit length is to be found. So in that case, since F is given by BIL sine theta, so here per unit length means F upon L is to be found. So BI sine theta, correct? So value of B is given as 0.15 Tesla. So 0.15 into current is 8 ampere and sine 30 degree. 30 degree means 1 by 2. We can simplify. So 0.16 into 4. Sorry, 0.15 into 4, which will become 0.60 Newton per meter. Correct? So you have understood. Question number 6. Question number 6 says a 3 centimeter wire carrying current of 10 ampere is placed inside a solenoid perpendicular to its axis. The magnetic field inside the solenoid is given by this. What is the magnetic force on the wire? So what is situation? Situation is very clear. So this is a solenoid, right? So field of solenoid will be in this direction, right? And the wire is perpendicular to it. So you can say theta is 90 degree. And here we are given the length of wire. Formula is F equal to BIL sine theta. Theta is given 90 degree. Magnetic field is given 0.27. B equal to 0.27 into, here it is 5 centimeter. Let's make it clear. Sorry, not 5 centimeter, it is 3 centimeter. So F equal to BIL sine theta. B is 0.7, 0.27. So 0.27 into current is given as 10 ampere. Length of wire is 0.03 and sine 90 degree. Sine 90 is 1. So this will become, we can write this 27 into 3 into 10 into 10 to the power 2 to 4 minus 4, right? So this will become 81, 810 10 to the power minus 4. So in standard form, 8.1 into 10 to the power minus 2 Newton, right? Now let's go to next question. Next question says two long and parallel straight wires A and B carry current of 80 ampere and 5 ampere. So there are two wires. One wire is this, it has current 80 ampere. There is another wire which carries current of 5 ampere, and the separation between them is given as 4 centimeter, right? Estimate the force on 10 cm section of wire A. So force between the two current carrying wires is given by mu naught I1 I2 divided by 2 pi r, right, times length on which force is to be found. So here all information is given, so we can put the value here. We can multiply by 2 so that this will become mu naught upon 4 pi, that is 10 power minus 7. Then I1 is 80, I2 is 5 into twice of length. So length 10 centimeter section, so it means 2 into 10 centimeter, 0.1 meter, divided by, just we have to write r, distance is 4 centimeter, so 0.04, right? Now let's simplify it. If we simplify, what do we get? F equal to, from here 2 power will get reduced, so it will become 10 power minus 5, and here 1 power will increase. Then the numbers left is 80 into 5 into 2 divided by 4. 4 20 times, so this is 100, 200, 200 times 10 power minus 6, which is 2.0 into 10 to the power minus 4 Newton, right? We can recheck it if there is any problem. F equal to mu naught upon 2 pi, mu naught I1 I2 2 pi r. Here we are given the values, mu naught upon 4 pi, we have multiplied, that is 10 power minus 7. I1 is 80, I2 is 5, then twice of length is 10 centimeters, so 0.1 into 2 divided by separation 4 centimeter. This is correct. Now what we have done, here power is reduced by 2, so that is why minus 5. Here power is reduced by 1 further, so it is minus 6, and then numbers are left, 80 into 5 into 2 divided by 4, 20 times, so 20 into 5 into, so this will become 100, 200, 200 to the power minus 6, so it's correct. Now let's see next question. A closely wound solenoid 80 centimeter long has 5 layers of windings of 400 turns each. The diameter of the solenoid is 1.8 centimeter. If the current carried by it is 8 ampere, estimate the magnitude of B inside the solenoid near its center. So what is rule? B due to solenoid is mu naught Ni, where N is number of turns per unit length. So here mu naught, we can put the values of all But before that, we must know what is N. N equal to number of turns. Total turns, 400 turns, 5 layers. So 400 into 5 divided by length is 80 centimeter. So 0.8. So this will give 2500. So we have got the value of N as 2500. Now mu naught is 4 pi into 10 to the power minus 7 into 2500 into current. Current is 8 ampere, right? So let's evaluate it. What do we get? So 4 into 3.14 into 2500 into 8 into 10 to the power minus 7, and we can evaluate it. So it will be around 2.5 into 10 power minus 2 Tesla. We can do it. Now, question number 9. A square coil of side 10 centimeter consists of 20 turns and carries a current of 12 ampere. The coil is suspended vertically and the normal to the plane of the coil makes an angle of 30 degree with the direction of uniform horizontal magnetic field of magnitude 0.8 Tesla. What is the magnitude of torque experienced by the coil? So if you remember, when we talk about torque, so we say tau equal to NIBA sine theta, right? Here theta is the angle that normal to the coil makes with the magnetic field. So here angle is given as 30 degree, so sine 30. Other factors are given. Number of turns is 20, current is 12 ampere, magnetic field is given as 0.8 Tesla, and then area. This is square, side is 10 centimeter, it means 100 into 10 to the power minus 4 multiplied by sine 30 degree, that is 1 by 2. So we can simplify it further. So this will become 10. 10 multiplied by 12 multiplied by 8 divided by 10 into 100 multiplied by 10 power minus 4. Right. So let's arrange powers. This is 96 into 10 to the power minus 2. There is no problem. Or 9.6 into 10 power minus 1. Or you can write 0.96. That will be better. And this is torque Newton meter. Right. Now, let's go to next question. Question number 10 says, two moving meters M1 and M2 have the following particulars. R1 is 10 ohm, N1 is 30, A1 is 3.6 into 10 power minus 3 meter square, B1 is 0.25 Tesla, R2 is 14 ohm, N2 equal to 42, A2 equal to 1.8 into 10 power minus 3 meter square, B2 is this much. The spring constants are identical for the 2 meters. Determine the ratio of current sensitivity and voltage sensitivity. So if you remember, NIBA equal to K times phi. Here we have to find out current sensitivity, and current sensitivity is equal to phi upon I. So phi upon I will be equal to NBA upon K, right? So there are 2 meters, so for them we can denote it phi upon I 1 divided by phi upon I 2 equal to, let's write the values. So for first one, since this is first, so here NBA N1 B1 A1 divided by N2 B2 A2. Let's put the values. So this is 30 multiplied by N1, then B1 0.25 into A1. A1 is 3.6 into 10 to the power minus 3 whole divided by N2. N2 is 42 into B2. B2 is 0.5 into A2 1.8 into 10 to the power minus 3. So here these two will cancel out by twice. Here this will cancel it twice. So 2 will cancel out. Then here 5 6 times, sorry, 6 5 times, 6 7 times. So we will get ratio 5:7. So we have got the ratio of current sensitivity of first to current sensitivity of second. Now suppose we want to find out voltage sensitivity. So for this we write phi upon I R1 first divided by phi upon I R2 the second, correct? This will give ratio of phi. So phi upon I of first divided by phi upon I of second multiplied by R2 upon R1. Phi I1 upon phi I2 we have already evaluated, right? Either here I1 I2 in place you can write M1 M2, that is same thing. So this value is equal to 5/7. So what more we have to run? We have to do, that is 5/7 times R2. R2 is 14 and R1 is 10. This is 14 divided by 10. So you will get 70 upon 70 and that is 1. So we have got the ratio of voltage sensitivity. Now there is another question. Another question says, in a chamber, a uniform magnetic field of 6.5 Gauss, where 1 Gauss equal to 10 power minus 4 Tesla, is maintained. An electron is shot into the field with a speed of 4.8 into 10 power 6 meter per second, normal to the field. Explain why the path of the electron is a circle. Determine the radius of the circular path. So generally what happens? Centripetal force is provided by the magnetic field. That is why the particle goes in circular path, right? So here we are going to evaluate what is the radius. So if we say that centripetal force is provided by magnetic force, so mv square upon r must be equal to qvb and sine theta. Theta is 90 degree because in our question it is given that normal to the field. So we just write this here, we will cancel out. And what is our concern? Our concern is to get value of R. So R will be equal to mv upon q times b. Let's put the values. We are talking about electrons. So electron means mass of electron. It is 9.1 into 10 to the power minus 31 into velocity. Velocity is 4.8 into 10 to the power 6 divided by charge on electron 1.6 into 10 to the power minus 19 into magnetic field, that is this is 0.6. So we can write 6.5 into 10 power minus 4. Now let's further simplify it. So we can remove decibels. So 91 multiplied by 48 whole divided by 16 multiplied by 65 times 10 to the power minus 31 plus 6 plus 19 plus 4. Let's simplify. So you can divide it. So I will write its value. First let me calculate this. So 25, 29, 29. So 10 power minus 2. Right. So if you evaluate this, this will come out to be 4.2. So this much. Correct. So you have got the value of the radius in this case. Now let's go to next question. Considering the above problem, obtain the frequency of revolution of the electron in the circular orbit. Does the answer depend on the speed of the electron? So let's see. We have got the value of r in previous question. The radius is we have got 4.2 into 10 to the power minus 2 meter. Now we have to find out frequency. So frequency means what? If this is r, velocity is v, so time period is equal to 2 pi r upon v, and 1 upon time period is frequency, so that is v upon 2 pi r, right? So let's put the values. V in our question is given 4.8 into 10 power 6. So 4.8 into 10 to the power 6 divided by 2 into 3.14 into radius we have got as 4.2 into 10 to the power minus 2. Correct? And then we can simplify. So this will come out to be 18 into 10 power 6. So nu or F equal to 18 into 10 to the power 6 Hertz. Correct? Now, let's see next question. Next question says, a circular coil of 30 turns and radius 8 centimeter carrying a current of 6 ampere is suspended vertically in uniform horizontal magnetic field of magnitude 1 Tesla. The field lines make an angle of 60 degree with the normal of the coil. Calculate the magnitude of the counter torque that must be applied to prevent the coil from turning. So normal torque equal to counter torque. So torque is NIBA sin theta. Right. So here we are given values. N is 30. Current is given 6, magnetic field is given 1, area of the loop. Here the radius is given 8 centimeter. So we can write it 3.14 into 0.08 whole square into sin theta, sin 60 root 3 by 2. Right. We can evaluate it, and this will come out to be 3.1 Newton meter. 3.1 Newton meter. Now let's see second part of the question. Would your answer change if the circular coil were replaced by a planar coil of same irregular shape that encloses the same area? So actually we have to consider the area, not the shape. So if area is same, then nothing will change. And hence the exercise is over. I think you have understood. Thank you for watching. Team Educate.